Hello, welcome to Building Maintainable Command Line Tools with MRuby. I'm Eric Hodel, and this is a talk about working with MRuby and MRuby CLI. So I'm a Ruby committer, a Ruby gems committer, rake committer, and the author of many gems. But mostly I'm on vacation from these. Instead of working on Ruby in my free time, I've been spending a lot of time making shelves like these. This one close to me here is a work in progress still. I'm trying to fill in that little gap there. I work for Fastly, a real-time content delivery network. This is our website featuring Gordo, one of our amazing Fastly office dogs. Fastly supports open source, including hosting the RubyLang website and all of the Ruby gems, including the downloads. We have a Japanese Twitter account at Fastly Japan, so you can follow us there. So in part one, I'll cover a bit of the background of what MRuby is and what MRuby CLI is good for. So my exploration of MRuby and MRuby CLI started with a web API wrapper. We're building a new product at Fastly, and it's got new APIs, and I wanted an easy way to interact with it so that I could demonstrate that the APIs are usable. So why not choose CRuby instead to write the wrapper? When we want to release something with CRuby, the user has to install the right version of CRuby so that they can so you can use the right features that you want. Then you also have to install any gems that you depend on. And then you have to go and maintain those and tell people to update as long as you're supporting the tool. And this is a lot of work for your users. MRuby is very similar to CRuby. So we can start with a prototype in CRuby, take that code and port it over to MRuby, and then continue to maintain it in MRuby. And then it'll be less work for the users. So what is it about MRuby that makes it more suitable? MRuby is a lightweight Ruby implementation. So you only need to use as much of the MRuby features as you need, which keeps your project smaller. It's also designed for embedding. So you can run Ruby on a low resource hardware like Arduino or Lego Mindstorms or some robots or like in set-top boxes. Or you can embed it in other software, which is much easier than trying to embed CRuby in software. And like CRuby, MRuby has libraries and calls them gems. MRuby ships with a very limited standard library. So you use gems to build up to the standard library that's more like the CRuby standard library. And there's also standalone MRuby libraries, some of which are C extensions. Like there's a C wrapper for the curl tool called MRuby curl. And at past RubyKaigis, there have been many other talks about MRuby. And so if you want to see other applications, check these out. And there are 3 other talks about MRuby at this year's conference, including one tomorrow. And you can find recordings for all these talks on the RubyKaigi website. Since MRuby is compiled, unlike CRuby, how do you use it? How do you get started? So the first thing you do is you edit your build config. Unlike CRuby, where you can load any gem at any time, in MRuby, you must choose in advance which pieces you want to use. In the build config, you also pick which MRB gems you want to use. You choose which compiler in case you're cross-compiling. MRuby CLI uses this to build for different platforms. And you also specify the library paths you use if you want to link in any C libraries like libcurl. And you can have many builds happen for many different platforms all in one compile step for MRuby. If you're writing an MRuby gem, instead of embedding MRuby in some other application, you'll fill out an MRuby gem specification that goes in the MRB gem.rake. MRuby CLI applications also use an MRuby gem specification. It's an easy way to go and specify all the dependencies and the executable names and all of your test files. The MRB gem.rake is where the MRuby gem specification lives. Like a Ruby gems gem specification, it contains all the gem metadata, the dependencies, the list of binaries. So metadata also includes the name of the gem, the version, which license it uses, and those kinds of things. You also specify the gems that you depend on and the binary that the gem is going to create. So once you've got these files all configured, you run rake, and then that'll cause MRuby to build all the binaries and executables and all the libraries. And then once it's complete, you'll see all these executables in the bin directory. So if you're using MRuby CLI, your CLI name will be there. You'll have an MRuby and an MIRB, and you can use these to write simple scripts or do little tests. And there'll also be an MRB test executable, which is the test runner for your unit tests. The goal of MRuby CLI is to allow rubyyists to build single file executables in a familiar environment. Last year, Terrence Lee and Zachary Scott gave a talk about MRuby CLI that showed the basics of the tool and how it worked. So you can check that out for a more extensive overview. The very basic description of MRuby CLI is that you can write Ruby and release software on Linux, on OS X, and on Windows. The typical development loop of using MRuby CLI is to start by writing some MRuby. Then you compile the code that you've written. Then you run the tests, and you go back to the start if your tests don't pass. And then once all of your tests are passing, then you can release the executables. So when I first heard about MRuby and MRuby CLI, I thought it would be pretty easy, but I was sure that there would be some challenges involved because it was a different Ruby implementation. So the first one is that MRuby is not the same as CRuby. The implementation doesn't support doing everything that you would do in CRuby like I'm familiar with. The first problem that I ran into was the modular standard library. MRuby's core classes are like string and array and hash are all very limited. They only support the minimum number of methods that you would need. So for the full CRuby experience, you have to add in the extension gems, like for array, MRuby array ext. And it's easy to forget to do this if you're developing your own MRuby gem. You might forget to add the dependencies. It'll work because your MIRB or MRuby might have all the dependencies, but not the gem itself. So then when you go and use your gem in another project, it won't work because you're missing parts of array that you're using. MRuby also has a smaller language outside of the standard library. There are no predefined globals such as load path. Everything is compiled because everything is compiled in, nor any of the globals inherited from Perl or shell scripts. And some libraries you may want to port over to MRuby may depend on these, so you'll have to add workarounds. I also had a problem with here document support when porting a library from CRuby, but I haven't yet reproduced it to file a good bug report on it. And while you can use keyword arguments to call methods, you can't define methods that automatically check for keyword arguments like you can in CRuby. And also, some of the gsub replacements don't work in MRuby, so you may need to change your regular expressions to get gsub to work correctly. Backtraces in MRuby have seemed less useful than in CRuby. There's an issue where the backtrace line number is sometimes off by a few lines. So when you have an exception, you have to be really careful to figure out if the line that the backtrace has is the one where that error was really occurring. And it also felt like I did much more exploring in the C sources than I did with CRuby projects when an exception is raised, but I'm not sure if that's unfamiliarity with MRuby or for some other reason. And there are many pure Ruby libraries already written in CRuby that you'll want to use in MRuby to make your life easier. And overall, it's pretty straightforward to port from CRuby to MRuby, but you have to be aware a bit of the restricted syntax. There's some things that are just different. Unfortunately, porting the tests is much more difficult because there are differences in the way the tests are run, and I'll cover that a little in the future. The gems for MRuby feel a lot more like working with libraries from Ruby 1.6. And I think this is because there haven't been enough people working in MRuby to build up libraries where it'll cover a lot of different problems well. It's usually only one problem that it solves well. And because MRuby libraries have this narrow focus, you'll either have to do a bunch of hunting to find the library that matches your use case, or you'll need to submit patches to get the library to work the way you want. And so far, I've submitted patches to all of these libraries, the Oniguruma regular expression library, curl wrapper, IO wrapper, the HTTPS client, and to MRuby CLI, and for some of these, multiple patches. And the last challenge I'll cover for MRuby is getting the build information out of MRuby. Since MRuby is compiled, it needs to link in C libraries to compile successfully. And with MRuby CLI, you need to cross-compile some of those C libraries in order to, or with the correct C compiler. And it's hard to get the information about which compiler you need to use and all the information to cross-compile successfully out of the MRuby build system without loading all of its rake files, which is a little slow. And so I think improving this will also make MRuby's build system more flexible, but I just haven't tried fixing it quite yet. MRuby CLI, like MRuby, was a new tool for me, and it took some time for me to learn the best ways to use it. And here's some of the larger challenges I've had with it. The first was Docker. So the MRuby build system is built on top of Docker. And the best part of this is that it's ready to cross-compile Linux, OS X, and Windows out of the box without any extra setup. Unfortunately, Docker is rather clumsy to use the way that MRuby CLI uses it. Typically, Docker is used to run a long-lived service, but MRuby only needs to keep the container running long enough to finish a compile or to run some tests. However, of all the options available, Docker seems to be the best because there really isn't anything extra you need to do to get started with MRuby CLI. It's very simple. And in order to start using, or to start a build of your command line tool, you run docker compose run compile. And this is just way too long to type, even if you know your shell history well. And there's a problem where if there's a problem with the compile, it's hard to debug from the outside. You have to start a shell that inside of Docker and then figure out which commands you are running, and then run those to try to reproduce it, and then you can fix your problem. And when you're working from a Docker shell, you don't have your familiar development environment, and there's no shell history from the last time you ran a Docker shell, so it's harder than usual to get things fixed. And I think the biggest challenge I've had with MRuby CLI was the build system. Most of the problems come from the way the tasks are organized. So the way it works presently, the tasks for building your MRuby CLI executable and the tasks for building MRuby are all mixed together in a single rake command. And this makes it hard to add your own tasks and then have them run in the right place. For example, before compiling MRuby curl, the extension, I need to have the MRuby C library built and installed for all of the platforms. But that's very difficult to do by default. And due to these difficulties, I've made some improvements to the build tasks. The first was to build MRuby separately from the other work that needs to be performed inside of Docker. And this means I can cross-compile C libraries at the right time. The other improvement was to have a rake file that exists outside of Docker and starts Docker for me. And then this allows me to perform extra tasks that don't need Docker to run and are easy for me to debug. So the new build system runs rake 3 times. First, the outer tasks run any of the tasks that don't need Docker. And so then those start up Docker and run the inner tasks. And they perform any cross-compilation or any extra setup that needs to occur before building MRuby. And then finally, that spawns the MRuby build process, which builds all the command line tools. Since the outer tasks don't need Docker, I use them to download MRuby and get it ready to compile, or to run some global test setup, or to, when it's time to release, they'll be all the release tasks. And since they're outside of Docker, it's in a familiar development environment, and I don't need to do as much debugging work or fighting with Docker to get things figured out. The inner tasks that run inside Docker cross-compile the C libraries that you have configured. Then they invoke rake a second time to compile MRuby and run the tests. And there are some additional benefits to the changes that I've made. It's now much easier to add hooks for custom tasks since there are well-defined places for different phases of the build. And I also made rake test faster by compiling only for the host platform when running tests. There's no need to build for every platform when I can only run tests on the host Docker platform. And it's likely you'll need to use a C library as a dependency in an MRuby gem in your project. And there's two options for how you can include C libraries. The first is to use static linking. So this embeds the external library inside your executable and keeps you with a single file executable. The advantage here is that you don't have to provide any instructions for installing the correct C libraries in order to use your tool. However, the downside is that if you may need to re-release the gem if there's a security vulnerability in that C library you're using. And it also makes the executable larger. The second option for dealing with C libraries is to use dynamic linking. And the advantage here is that vulnerability management is easier. So if there's an exploit, then the user should update that C library, and then all of the applications on their system that use it get updated at the same time. So there's nothing you as the CLI author need to do other than say, please update. The disadvantage of this is that it is an external dependency, so you're no longer truly a single file, and you have to have extra instructions for installing. The final large challenge I had with MRuby CLI was cross-compiling these C libraries. MRuby CLI can cross-compile your executables for 6 different platforms. And this means that those C library dependencies also need to be compiled for those 6 different platforms. For example, for libcurl, you can't just install the libcurl development package inside of Docker. It'll only work for the host system. It won't work for OS X or Windows. Instead, you have to download the source, unpack it, cross-compile it with the right cross-compiler for each platform, and then after that, set up MRuby to go and use each of the different cross-compiled libraries you've built. To help myself out, I wrote a small tool to automate cross-compiling dependencies. So you can configure the library to cross-compile with a few values. The first is its name. For this one, curl. And then the release name is used to create the source directory, since libraries don't necessarily use consistent names, so we can't figure it out automatically. And then you have a URL where you fetch the source from. And then optionally, you can set configure flags. For example, I don't yet have OpenSSL cross-compiled, so I disabled it because our development environment doesn't use any SSL stuff. So in part 2, I'll discuss the origins and the structure of the command line tool. So my exploration of MRuby CLI started from a tool our customer support team could use to configure the new service we're developing. Our service was, and still is, API only. There's no web UI for anyone to use. And the service has a very complicated setup. So I wanted to automate some of the common use cases to avoid errors. And I also wanted to have a tool that our customer support team could send to customers to reduce the burden of supporting this new service. And the solution to these problems was to write a tool that would automate the setup, validate the user's inputs, and reduce the errors the users could encounter. It would have the benefit of giving the design feedback on our API, and we could use that for further improvements. And before exploring MRuby CLI, I started with some prototypes in CRuby. The first was a single file script that primarily served as documentation. The script was very easy for me to write. Customer support could modify it for their needs, but it wasn't flexible enough to handle all the ways they interacted with the API. So as the needs of customer support grew, I split that single script out into multiple scripts. Each one had its own purpose. For example, listing options, or doing initial setup, or disabling or enabling some features. And this was more flexible, but I also made a point of making sure the scripts were well documented, so it would be easy to modify the scripts in the future. And finally, I extracted a couple of classes from those scripts for reuse. And this included a basic implementation of the JSON API, as that is our API transport specification, and one for argument parsing using Ruby's option parser, as we have many commands that use many of the same arguments. So what lessons did I learn from these prototypes? The first was that documentation in the tool was very important. We had not yet budgeted time for API documentation for the service, so documentation via the command line tool is very useful. It turns out that roughly half of the lines in the scripts were comments, and this meant that our support staff could figure out what the tool was doing and suggest changes to us that would improve their lives. Keeping the scripts simple made everything more understandable. None of the scripts had external dependencies, so they were easier to install, or so to speak, by checking out the repository. Most scripts were very small with a well-defined purpose, and it was OK to have a large script that automated an important action. Ultimately, though, these were very hard to maintain. Our development environments install an old version of Ruby. It doesn't have the keyword arguments that made the scripts easier to read, so we needed to have them install a modern version of Ruby to use them. And customer service would add some of their own tools, since implementing the new tools was easy due to the documentation. But then they would have multiple independent versions that were hard for both of us to support. I decided to investigate a switch to MRuby CLI to address the maintenance burden while trying to keep the maintainability high. I decided to model my command line tool off of the pattern in RubyGems. The subcommands in my command line tool are implemented as one subclass per subcommand, the same as in RubyGems. They both use option parser to parse arguments, and there are two methods in the API. A setup method for specifying which command line options the subcommand supports. And after parsing all the arguments, then the execute method runs the command and handles any errors. For example, if we had a command that listed conditions, the setup method would require a service and a version that the conditions are attached to. And then the execute method would take those arguments, perform the API operations to fetch all of the conditions, and then display them to the user. So in order to implement this in MRuby, I ported the MRuby opt parse from the CRuby standard library. I chose this because it was familiar to me and to other Rubyists, and it has good documentation. Opt parse also performs automatic type checking and argument completion for you, which means there's less code for me as the implementer to write to check all the arguments by hand. And opt parse even offers shell completion as a standard feature. And all these would make parsing arguments easier and straightforward and would make the tool easier to use. For API requests, I chose MRuby curl. I evaluated several other HTTP libraries for MRuby, and this one seems to be the most mature. It supports both HTTP, which is used in our development environment, and HTTPS for accessing our production systems. The library supports persistent connections, which is especially important for HTTP requests to keep them speedy. And the only downside here is the libcurl dependency, which must be cross-compiled and linked into the tool. For testing, there are two MRuby gems that seem to be the most popular. The MRuby mtest gem provides a library for assertions, while the MRuby test gem provides the tool that runs all of the test cases. While using these gems is very easy, setting up the test cases can be pretty painful. Testing gave me the most frustration when building the command line tool. It's the most important piece of writing maintainable software, but due to the unfamiliar environment, there was a lot of adjustments I had to make in order to understand testing with MRuby and MRuby CLI. The MRuby mtest gem is very much like Minitest that ships with CRuby. You make a subclass of the test class. You write test methods, the same as in Minitest. There's a setup and a teardown for a common test setup across the same test case. But you have to remember to run the test suite at the end with this line because there's no @exit hook by default. It's an extra gem in MRuby. And since MRuby is compiled, you don't run the test directly with MIRB. Instead, you use the MRuby test gem, which provides a test runner. Unlike CRuby, each test file gets a new MRuby VM. And so this gives you complete isolation between different test files. The design of the test runner has some complications to it. The first is that creating a global test helper requires setting up test preload in your MRuby gem specification. And I didn't learn about this until yesterday. So I haven't been able to get it to work right. And also, the other complication was Docker. So MRuby CLI uses Docker Compose, but most of the documentation I found is written for the Docker command. So it took me some time to figure out how to set up the DNS records so that the tests could talk to the development services on my local machine. I would have preferred to have mocked all these out, but I'd have to write all that in MRuby, so the development trade-off was too high. And the final complication was that MRuby CLI was slow to start running tests because it would compile all of the platforms before running any of my tests. So this made the feedback loop very long when I was making small changes to get a test to pass. To work around the global test setup, I chose to perform the bulk of the test setup in Ruby before starting any of the tests. And then I used the improved build infrastructure to do this outside of Docker, where it's easy for me to work. And since I only learned about the test preload yesterday, I'm passing the data needed from the global setup into the tests using environment variables that the test could look up when it needs them. And to improve the test startup speed, I've adjusted the rake tasks to only build for the host platform, which is what the tests use. And then this meant I only had to compile 1 platform instead of 7. MRuby CLI supports bin tests or integration tests. And since I prefer strong unit tests, I haven't explored these much. For an integration test, you can run your command and then assert the output it returns. And so now we're approaching the end. What would I like to see to make MRuby and MRuby CLI easier to use? For MRuby CLI, I'm going to contribute back the improvements I've made to the build system. I've already had some discussions with the authors about the improvements I've made, and the maintainers seem positive so far. The documentation for MRuby CLI could use some improvement, as it isn't obvious where to start, or what complications you run into, or what some good ways to work around those are. And I'd also like to make upgrades to new versions of MRuby CLI easier. Right now, the way it works is you kind of take the changes you've made to your rake file and try to port them to the new system. But if the change is big, that gets more and more difficult. I'm not sure. I don't really have a plan about how this should work out yet. For MRuby, I'd like to see more accurate backtraces. Right now, you have to pay extra close attention to figure out which line MRuby meant so that you can actually start working on the exception you're having. I also want to separate the loading of the build configuration from generating of the rake tasks. So this will make it easier to integrate MRuby's build system with MRuby CLI's build system. And finally, I like to see keyword arguments in method definitions. MRuby's C API is a very fancy implementation of argument checking, so I'm unsure how this will work with keyword arguments. And of course, working with MRuby has shown me some stuff I'd like to see in CRuby. One of those is C API called MRB getArgs. And in the MRuby C API, this function extracts the method arguments when a Ruby method calls into a C function. In MRuby, this function allows you to specify the types of all the arguments, and it provides automatic type checking and conversion for you. So it's very easy to go and write a C method in MRuby. The equivalent method of this in CRuby is rbscanargs, but it's much less expressive since it can only check the number of arguments and what positions they show up in. Finding test preload was difficult. I read the documentation twice, and it wasn't until the second time, months later, I was like, oh, this looks like it's the thing I want. So I think some more documentation there and some examples would help make this more obvious. Also, it would be nice if there could be some automatic setup for this, so maybe a special file name will get picked up and become a preload automatically. Also, MRuby test runs all of the tests and doesn't have any options for filtering by test name or test file. So if you want to make a change that's going to touch a lot of tests, but you know it only has to run a few, you have to go and scan through by hand to go and find out which error you actually care about. So having a name option like the mini test or the RSpec has would be much more helpful. Thank you. Are there any questions?
誰か質問がありますか？ワニートのほかには Not Juanito, anybody but him. No. He's okay.
Is there any gen to open browser in MRuby?
So to open a browser in MRuby, you would link in to the C library of a browser, and then you could drive that through MRuby. This morning, Kohei-san showed a GTK WebKit binding using GObject. And so you could probably link MRuby to GObject and get all that stuff. So yes, that's possible. Go review his talk for ideas on how to do that.
Okay, ありがとうございます。
Yeah, it's the C APIs between MRuby and CRuby are very similar, so there's not much to learn there.
Thank you for your good presentation. My question is that what is the most important advantage of MRuby CLI to its rival, like Golang CLI? What's the most important advantage?
So what makes MRuby CLI better than Go or other tools? I'm a Rubyist, so I know Ruby very well. I don't know Go very well or any of the other languages, so I can get MRuby CLI started and teach the rest of my team about it, and they can develop more quickly as opposed to learning a whole new language and developing from there.
Yeah, that makes sense. Yeah, thank you.
Any other questions?
あとは
Zach.
Hey, so you mentioned that debugging was hard because the stack traces.
Yes.
Was this with debug mode on, where you get the stack trace info?
I don't think I have debug mode on, but I did notice the line numbers are often off by 1 or 2 or 5. Yeah. So I don't know if debug mode helps with that part, because sometimes it would be a typo and it would be like, this line is fine. There's no typo here. So you have to go back and read it again and go back and like, okay, it's actually the line above it or more above it. I'll try debug. Tell me about debug mode after, and I'll.
Sure.
Yeah, thank you.
Thank you.
And I think for the backtrace or for the line number stuff, I should go and make minimal reproductions so that we can figure out where it's off.
Do you have any experience using the testing in like a CI environment?
Yes, so I have set up MRuby CLI with Travis, and it loads up Docker and does all the rake tests and runs through everything. At Fastly, we have one of our dependencies is a private gem, so there's an issue there where we needed to set up a deploy key to get it to work right. But other than that, the tests run in, at least in Travis, without any difficulty. No more?
もうありませんか？そのぐらいにしましょう。どうもありがとうございました。